Really cool. I think they had a hack.
Right.
Alright, I think we're going to get started, folks. Thank you everyone for coming to this month's DCRUG. First, quick show of hands, who is at their first meeting of the DCRUG users group? Okay, a couple of you folks. We are a group that meets monthly to talk about Ruby, Rails, and related technologies for people in and around Washington, D.C. We cater to all levels of experience, from people who have never touched Ruby before but are interested in it, to people who are Ruby gurus. It's a chance to learn some more about the technology and to meet people with fellow interests. Typically we have some presentations, usually 2. Today we have 2.5, I guess we could say. 3?
2 1/4.
2 1/4. We then go afterwards to a bar to socialize, have a few drinks, chat. I think we're going to try a new bar this month. We're going to try RFD a little further up the street, see how it does in terms of space and noise. People found it, I think, a little hard to have conversations at Rocket Bar. We'll try RFD, maybe we'll go back to Rocket Bar next month, but we'll see. I want to thank our host, Logic, for providing this space. It's not easy to find a good quality, sizable, free space that is metro accessible in Washington, D.C., believe me, so we appreciate that. Logic employees, if you want to raise your hand and play it up there. Legally Discovery. I'd also like to thank Intridia, our sponsors, for providing the projector, the pizza, and the soda. Intridia is a Ruby on Rails and mobile consulting company based here in Washington. Want to ask real quick if anyone here is looking to hire folks. Can you raise your hand real quick? All right, sure. Okay. So, you are.
Okay. My name is Patrick Peak. I'm the CTO of Browser Media. We're an interactive agency. We're looking for front-end web developers as well as Ruby folks. So if you're interested, I'll be the bar afterwards.
Okay, I realized I just didn't introduce myself. Sorry, I've been doing this
want to get in?
so long. I'm Joe Grossberg. I organized this meetup. I work for a company called SB Nation now. We are looking to hire front-end, back-end developers, as well as a variety of other positions. If you're interested, please come speak with me. Also, by all means, add me on Twitter, Facebook, and the like. Also wanted to thank our speakers. We have Jeff, we have Avi, and Joel. There you go. Joel in the back are going to be giving presentations. We're going to start off with a short one by Jeff, and he wants to get some feedback. Then we'll do Avi and Joel. I also want to thank JP for setting up the camera. We are, for the first time, recording this so that we can upload a video of it for folks who weren't able to make it, so that they can still see the presentations, and I thank the speakers for letting us do so. Do we have any other announcements that people want to make? Yes?
So last night we did the first Learning Ruby meetup and had 4 people who are here tonight were there last night, so I see you more than my wife. It was pretty successful. We had 12 people. It was me and one other guy who were kind of coaching, 10 people learning. Worked out pretty well. We expanded to 18 for the next meetup, but then it sold out in an hour or 2. So I'm not sure how we're going to fix that exactly, but the intent of it was to try and relieve some of the pressure from DCRUG, having 50 signups and then 40 people on the waiting list, and now, I won't say it's backfired, but it has not solved that issue. It's kind of like a study group kind of thing. It's not really, I didn't want to do it in all sit in chairs and listen to me talk even more than when you're here. And so it's very informal, for you all to come. If you're here tonight and you actually show up for stuff, and next time you want to come, but it's full, send me an email and I'll probably just say come on down. My office is much smaller than the Logic space, so it's a little constrained there. I also started up a little bit of an unofficial DCRUG library at my office, and I'll locate it, hopefully to Living Social once they get their new space, but a bunch of Ruby and web development and design books and things like that people are welcome to borrow, and put together most of a little app that you can see what's on there. So I'll have that done the next week or 2.
Cool. Anyone got any other That's right. Thank you, Jeff, for organizing that Ruby Newbies thing.
Yeah, I got
feel
like
like
these nasty
demand
emails about
has expanded to fit the supply of space, but I guess Ruby is just a very vibrant, popular space to be in these days. All right, then without further ado, we'll start off with Jeff's presentation on how to blow up your views.
All right, so the backstory of this presentation is I got accepted to speak at a conference in June, and normally when I give a conference talk, I'll try and give the talk like 4, 5, 6 times to different user groups as I travel around. But this one, I only had a month's notice, and I couldn't really fit any user groups except tonight. And so I just started putting together a few of the first ideas, and I'm interested to see if you think like it's complete bullshit, or if you think like, oh, that's kind of interesting, or I have no idea what you're talking about. It's about the view layer. It's kind of inspired by thinking that I did after my last presentation, which was the fat models aren't enough. So yeah, this is kind of brainstorm quality. So don't throw too many tomatoes at me. This is the too long didn't listen version. Is that I think the way we do views in Rails is relatively stupid. Amen. They don't have an interface. They're the only part of the stack that isn't an object. I was actually one of the bits of research I did when I was thinking about that was go into a view and just have it output self. And before I evaluated it, I had no idea what I was going to get. So that's a little interesting exercise. Like, what is the self inside a view? Here we go. Let's go through them one by one. So when we think about the Rails stack, it's usually modeled like this. Request down through router, controller, model, back over to model, up to the controller, over to the view, up to the response. But the reality is that these two pieces actually have more than one job. And I kind of have a problem with this. When the request comes down to the router, first, this is the controller. The controller first does this request processing and figuring out parameters and that kind of stuff. Then goes down to the model, that goes over database back to model. And then the controller becomes a data interface to the view. Then the view has two parts of first formatting data, running things like helpers and doing calculations, whatever, stuff like that that's in there. And then actually rendering the template, combining the data with the HTML. And if you listen to like Uncle Bob Martin and single responsibility principle and so forth, if you can chart out two responsibilities for one component, then that's kind of a sign that you have a design flaw, I think. So we talk about data interface. What I mean is the part of the controller that gives data to the views. So if you want to supply data to a view, what do you do with it? Anybody?
You like make instance variables?
Make instance variables, right? And then if a view is not a class, how does it get those instance variables?
Magic.
Yeah, it's magic. They're actually, it pretends, or Rails gives you the illusion that the controller action and the view kind of live in the same scope, but then they don't because you can't just use local variables. And so it's like, well, are they in the same class? No, they're not, because if you echo out self, you'll see that it's an anonymous class, the view. So the data interface there is kind of a lie. What actually happens is Rails, at the time the action completes, it spins up the view, and then it copies all the instance variables that were in the action over to the view, which is generally accepted as a giant hack. Then the view takes that data and starts doing formatting with helpers or what have you, and then renders it out into the template. So this data interface is the first part that I object to, because an interface, the important part of an interface is that it's an agreement. And with our controller actions and our views, there's no agreement as to how those things are going to meet up. You just like define some variables and then you start using them. And sometimes I've worked on projects, my own projects even, where I realize down the road, like I've made instance variables, I'm not even using them in the view, or the opposite, I'm in the view and there's some instance variable I'm sure is accessible and it's not there. There is no contract between them. And they pretend to share this context, but they actually don't. And it's not an interface. These are actually just tightly coupled objects that you can't change one without changing the other. There's one proposed solution is this library called Decent Exposure. If you read the Rails 3-way or the Rails pause 3-way, they use Decent Exposure extensively. This came out of Hash Rocket down in Jacksonville. And it's pretty cool. At first I saw it and I was like, I don't like this. But the more I think about it, the more I like it. It looks like this. Well, I should say an original standard Rails class would look like this. Index, you pull all your articles, sort it into an instance variable, and then render that index out here. In Decent Exposure, you use this expose method, and you just pass in the symbol that you want to use, articles, and what it supplies you is a helper method with that name, and it has a bunch of default lookups on it. So if your helper is a plural of a model, it'll automatically do this same lookup, article all, and it'll do it as a helper within the controller rather than an instance variable. So you can get away from using instance variables in your code. It's not, you look at this and you're like, what is the point of that? It's actually, like from the theory, there's a big difference between using a helper method and using an instance variable, in that the helper methods are real things. They are a real interface that we can see and touch, as opposed to just kind of random instance variables. So that got me thinking more about how to break view templates and controllers apart. And if you had a true interface, the flexibility of an interface is that not only should these two pieces be loosely coupled, but either piece should be able to swap out for a new piece, right? So if our controller is an interface to our presentation layer, then really we shouldn't have to change anything about the controller if we want to present JSON, if we want to present XML. That stuff should just happen at the templating layer. Anybody read this article in Wired that proclaimed the web is dead? It was a great headline, I thought. That like kind of the web as we knew it is dying, in that everything is moving towards APIs. Like mobile and API are the future of what we do. And of course JSON powers most good APIs now. So I started thinking, what if our view templates were just API customers to our controller? So a controller just supplies JSON to everybody, whether it's an API request or a normal view template. Could we make that work? Could we unify on that interface? It would give you an actual interface. You might have a decorator layer, so I'm still creating helper methods for presentation logic because they're not object-oriented. They're mixed into this global namespace, and so I'm interested in decorator objects for that. And then have the decorator spit out JSON. Then at your view layer, combine that JSON with the view template. And then the part that got interesting to me was, what if the client rendered the template? Like rendering a template is relatively expensive. You have this big file, it's mostly text, and then the server has to wait for all these other things to happen, get the data, then stick the data in there. So if you were to push that down to the client, these are some of the gains you would have. Okay. And I'll get more into those details. With Rails 3.1, there's also this interesting part about flushing, or automatic flushing, that you can start sending data out to the client before you're totally done processing the request. And when I heard about this, I was like, oh, that's kind of cute. I guess you can like push some images out in your head or some sprites from your CSS or some of your JavaScript. Okay. And I was like, oh, if we combine this, there's something interesting we can do. This is how a traditional Rails request goes. Right? Request, router, controller, model. I've tried to make it somewhat representative of where the time is spent. So basically, the client makes this request, and then they're waiting. This is just the browser spins, right? While all these things happen. Eventually, the template is rendered, spits back the response, and then the client has to make more requests to you to get all your assets, your CSS, whatever, and that stuff spits back and happens JavaScript processing. All this is dead time. All this is the load on your server. Using this automatic flushing, I think we can reorder this. go request server, router, controller, JS assets, and start sending these JavaScript assets back right away, while this model and database query is still happening. So to your client, almost as soon as they make the request, they start getting stuff back. They start by getting the JavaScript libraries that they need in order to combine the data and JavaScript template. Then they get a template written in JavaScript or some kind of JavaScript compatible markup. And then finally, while all this has happened, you push out the data response. Now they can do the data formatting in JavaScript, process the template, and actually see the results. So to them, there's less dead time here. So like things are happening. But what's most important to us is that all this here is gone. So this server can now be serving other requests. Because the client, they probably have 2 processors just sitting there doing nothing. Their computer is likely almost as fast as your server. And so if we can push, the more of these squares we can push over their way, the better. So that's what I want to figure out. How do we do it? Right? So if you want to push out JavaScript compatible templates and data out to the client, make this interface that just retrieves data, just spits out JSON, and then send it out to the client. To the client, we need to give them a rendering engine. So we can't just give them like HTML. We have to give them an engine, a template, and the data. Okay? And then what does a rendering engine mean? One available is Mustache. Has anybody used Mustache for a project? It's okay. I'm not sure how I feel about it. It's made by GitHub. I think GitHub uses it like all across their site. It's got kind of an interesting format. There's also, I'm a Haml addict, and there are 2 libraries that do Haml in JavaScript. One's called JAML and one's called Haml.js that I think are interesting. There's Sprout Core, right? So if you really want to go heavy client, that could be all Sprout Core. And then others, I don't know, it seems like they're popping up all the time. If we put this framework together, I think these are the gains. You have more requests per second by your server because your server is doing less work. The time to the first response. So as soon as the client hits the request, they're getting data back. So they could be seeing things, even if it doesn't have all the data filled in. I don't think there's anything wrong with that. It's better than the white page. And unifying your API customers and your front-end customers makes for less maintenance work. I think it forces you to make your API really good too. Okay, so that's it.
So, all right, Avi, you are up. Thank you for coming all the way from Pennsylvania.
That's funny. So, I'm Opti. I've been giving a talk for a little while about exceptions and failure handling in Ruby, and Joe told me to keep this to about half an hour. So I was thinking about what can I show in half an hour that won't just feel abbreviated. So I'm doing something a little bit different tonight than I have been doing. I'm not going to do that whole talk. What I want to do tonight is just show you 5 things that you might not have known about exceptions in Ruby. And feel free to pull out your laptop. Some of these code examples are kind of fun to play with, so I won't be insulted if you're tapping away. To get started, who here has so far tonight learned nothing new about exceptions? Everybody should be raising their hands. Okay, so yeah, right. Since the start of this meeting, or since I started talking, let's put it that way. Okay, so my goal is to get that number down to 0 by the end of this talk. So we'll see how I do. All right, number 1. Let's start with something fairly basic, as this stuff goes. Retry. Ruby is one of the few languages that supports a retry keyword in its exception system. Where this comes in handy, if you've ever written code like this, where you have some process that may fail, maybe you have a web service that is a little dodgy and doesn't always get back to you in time, or doesn't always get back to you at all. So you surround it with a loop, and you have some kind of tries counter. You keep trying, eventually you say, okay, I'm done trying. I'm this up. Ruby lets us do this. You can supply in your rescue block for an exception, you can say retry, and what that will do is that will throw the process back up to that opening begin, and it'll start again. And so you can do things like check a tries counter in there and retry if it's not done, or if you're not out of retries. You can do things. You can get kind of crazy with this, but you can do things like switch something and then retry. So like if you have 5 different endpoints that you can try a request out on, you could try it out. If an exception is raised, you could switch to the next endpoint, try it again. So that's retry. Okay, hands up again. Who still hasn't learned anything? All right, we got a few left.
New to me.
All right.
And it works. It's not just maybe retry.
All right, number 2, the $bang global. So what the heck is the $bang global?
Is this Perl?
It's Perl. Yes, the Perl users in the audience will recognize this. The $bang is the global error value, and what it shows you is if there is currently an exception being handled, and what that exception is. So the $bang is either going to be nil if there is no exception currently being handled. So most of the time it's going to be nil. But then if you're in a rescue block, or if an exception is being raised up the stack, or you're in a rescue that is handling the exception, then $bang is going to be set to that exception, which is what this code here demonstrates. It also demonstrates that if you can't stand that $bang, that obviously completely clear $bang syntax, you can require the English library, and then you can call it error info, and that is an alias to it. Okay, that's all fine and good, but why? But how is that useful? So let's say you want to put a crash logger in your program. It's crashing. You want to know what's going on when it crashes. You want to get some kind of report, but you can't. You're in a situation where you can't put a big old begin, rescue, end around the entire program. For example, off the top of your head, how would you put a begin, rescue, end around an entire Rails program? It's not obvious how to do that. What you can do is define an add-exit block. Add-exit in Ruby will define a block which will, a handler which will be called as the program or just before the program exits. And so we can put our crash logger in this add-exit block. That's cool, but the problem is the program could be exiting due to a perfectly normal termination. So how do we tell that the program is exiting because of an unhandled exception? And that's where this $bang error info variable comes in. What we're doing here is we're saying at exit, if we are exiting because of an exception, we're going to do this crash log. And what this is doing is just opening up a log. It's dumping some YAML out. In this case, we're capturing the time, the error message, the error's backtrace, and we're also going to dump out the versions of all the specs, the versions of all the gems that were loaded at the time of the crash. Here's another example of using the error info variable. So in Ruby out of the box does not give us nested exceptions. If you're not familiar with nested exceptions, that's when you raise an exception and you rescue it, and then you decide you want to raise another exception. But to be kind to anybody debugging, you're also going to attach a reference to the original exception so that you can see where that, what originally failed. Here's an implementation of a very simple nested exception in Ruby, and the way we're being a little bit magical with the error info variable, because what we're doing is we're saying if nobody explicitly passes in an original exception, we're going to just discover it by looking at error info. And so here's an example of using it. We raise just a regular runtime error, then we rescue it and raise a secondary error. And notice we're not passing in the error that we raised here. We're not passing any kind of reference there. We're just doing a raise. But because that was done in the middle of rescuing another exception, we have magically discovered that the original exception was this error A exception. So there are two uses for the mysterious $. Yes?
Quick question before you get too much further. In the previous slide, we had some semicolons.
Mm-hmm.
Why? Oh, no, there, yeah.
Because every now and then I revert to my Perl days.
Okay.
Especially when I'm writing, I guess especially like when I'm using Perlisms like $. I sort of get back into Perl mode. That's the only reason I can think of that I put that there.
Where that at exit thing? Where would you put that in a Rails at?
You could put that in an initializer. Okay, that's one place you could put it. The other nice thing about that is that you could just package that up in a gem. I actually did this once. Got a gem called 00. That all you have to do is require the gem, and you have that error, that crash logger. You don't actually have to put the crash logger in anywhere. You don't have to put a begin, rescue, end anywhere. It's just requiring it puts it in, because requiring it loads that at exit.
Why do you think that in Ruby that it's not that common to use that? I mean, in Perl, it's like all over the place.
What?
That exception, the $.
Well, I think the biggest reason is, now it's been a little while since I used Perl and Anger, but in Perl, as I recall, there's no explicit, it's like this, there's no explicit argument for the error. So like, there's an example. Here we go. In Ruby, we can say, we can name the error. Here we're naming the error, the exception error. We're giving a variable to it, and then so typically in Ruby you'll just refer to it by whatever name you give it in the rescue. As I recall, in Perl there wasn't a way to do that. It was just you always use $bang. So all right. Before we go on to the next one, hands up. Who still hasn't learned anything new about exceptions? All right.
I think I've seen that before, I'm not too sure.
I might be ending this early.
Just call it.
I figured I'd have somebody who like read all the way through the book that I just put out and would just like keep their hand to the end. Okay, number 3. Raise. Raise is a keyword, right?
It's a method, because that screwed me around for a while until I realized I need to put parentheses in it occasionally so that I can do it within some sort. If you do it in sort of a line block or something.
Raise is just a method. It's just a method in kernel. Well, raise and fail, I should say. Fail is a synonym for raise. So yeah, it's just a method. And of course, this is Ruby, so that means we can override it. We can make raise do whatever we want. Here's a stupid example. We could make all exceptions instantly fatal. Who needs exceptions anyway? So here's an example of that. We're defining a new raise exit module. It's going to redefine raise, and all raise is going to do is it's going to put out the warning. It's going to put out the message on the exception, and then it's just going to exit the program. Include that into object, and raises are now instantly fatal. Yes.
Can you, I'm not very advanced with my exception. If I wanted to use this to make a certain exception always exit, could we do that?
Sure. You just put an if clause in there that says that takes a look at the exception. And now it's a little bit fancier than that, and one of the things we'll get to next explains why. Okay. Because it has to do with how we get the exception. But all right, so that's fun. This slide ran over a little bit, but if you want to see something, a potentially more interesting, more useful use of the fact that raise is just a method that we can override. I've got a game called Hammer Time, which tries to be a Lisp or Smalltalk style error console for Ruby, where instead of just raising the exception up the call stack as soon as you say raise, it interactively prompts you with some raising, like dropping down into a debugger at the point of raise to see why it's raising. So something fun to play with. Who still hasn't learned anything? Thank you. All right. When we say raise, it's just doing this, right? I mean, we give it a class, we give it a message. It's just saying that error class dot new. I left my comment in there, so I guess I gave it away. Error class dot new and the message. It's just doing that, right? Well, not exactly. What raise really does is it takes that error class, or runtime error if you didn't pass an error class, and it calls dot exception on it, not dot new. And dot exception is kind of Ruby's version of it's kind of Ruby's exception coercion method, you can almost say. It's like Ruby's got 2s to convert things to strings, and it's got 2a to convert things to arrays. Dot exception is how we ask something for an exception. However, by default in Ruby, the only place you see this defined is on exception. An exception actually defines it both at the class level and at the instance level. At the class level, it's equivalent to calling class.new, so it's just creating a new exception of that type. At the instance level, if you pass no more arguments to it, what it'll do is it'll just give you the exact same exception back. So when you rescue an error, you call it error, and then you say raise error, so you raise the same exception again, it's just calling dot exception on there, which is returning the very same object and raising the very same object of the chain. You could pass in a new message, in which case what it would do is it would duplicate that object, including any data that's included in that object. It would duplicate that object, give it the new message, and raise that up the chain. You could even pass in a custom backtrace. It would duplicate the object, set a new message, set a new backtrace, would keep everything else. This is kind of fun for clarifying exceptions, or I guess you could take information out too if you want to be mean. But if you have a little bit more context farther up the chain, you could say you could rescue the exception, clarify the message, and then raise it up again. So what else can we do with that? Well, there is nothing that says you can't implement your own dot exception methods. So here's an example of putting our own exception method on an HTTP response. And then what we're doing here is we're delegating the responsibility of what exception class to raise to that object. So instead of saying raise this particular HTTP error, we're just saying raise unappropriate exception for whatever you are, and then that can polymorphically decide what kind of exception should actually be raised for that kind of response. Who has anyone not seen anything new? Well, I'll just keep going anyway. So finally, let's talk about dynamic rescue clauses. When you look at rescue, it looks kind of familiar. I mean, the syntax of rescue looks kind of familiar. It looks a lot like Ruby's case clause, and cases in Ruby, case statements in Ruby are super flexible. You probably already know that. There's lots of cool stuff you can do with them. And as it turns out, this is not a coincidence. The way Ruby deals with rescue clauses is very, very similar to how it handles case statements. So one thing that means is we don't have to pass an explicit list of exceptions to rescue. So what we're doing here is we're defining this method ignore exceptions, and we're going to give it a list of exceptions to ignore. And then it's going to rescue that list. And what we're doing here, you may have seen this in a case block sometimes. You may not have seen it in a rescue block. We're just splatting out that exceptions list to before giving it to the rescue. So it's saying rescue any of the exceptions in that list, which is of course dynamic. Now we can say for this risky operation that might fail, we're going to ignore the exceptions IO error and system call error, and we do an open of a file that doesn't exist in there. The IO error that gets ignored. So that's one way we can exploit the fact that rescue clauses have the same kind of dynamicity to them as case statements. And that brings me to the end of the 5 things that I had queued up. But I've got some time left, so I threw in one bonus thing here. Let's talk about really dynamic rescue clauses. You may know that in Ruby case statements, the way it actually does the comparison, the way it decides whether a case statement matches the object, is it uses the three-equals operator, triple equals.
Did you call it three-equals?
I did call it three-equals.
Yeah, that's the new one.
It rolls off the tongue a lot better than triple equals. I like
it.
three-equals. I didn't invent it. I didn't come up with it, but
just claim.
I like it. Now I need to figure out who I first heard that from. So yeah, three-equals. But if you're familiar with case clauses, you know they use the three-equals to decide whether the case matches. Ruby rescue clauses do the exact same thing. They just have one weird little arbitrary limitation, which is that the thing which has the three-equals on it must be a class or a module. It can't just be some generic object. It can't be a regular expression. It has to be a class or a module. But in Ruby, we can create new classes and modules on the fly, and we can give them whatever methods, class level methods we want. So here, we're going to say, define a method called errors matching, and it's going to take a block, and the block will be a predicate for which errors to match. And then inside that, we're going to dynamically generate a new module because we have to give rescue a module or class, and we're going to stick three-equals on that module, which is the block that was passed to errors matching. So what this enables us to do is to do stuff like this. We can say rescue errors matching any exception where the number of tries, we're assuming that we've got an exception, a retryable exception that has a number of tries on it, is less than 3. And we'll assign that to E, and then we'll handle that a particular way. So now you know how to specify at any level of atomicity which exceptions to rescue and which to ignore. And that is it. If you found this interesting, I recently, actually just last week, I released an ebook on this topic, all about exceptions and error handling and going way into even more detail than I just did. And so it's at exceptionalruby.com, and you can use this code to get $5 off, which makes it $10. And feel free to, you can pass it on, you can tweet that out, but it's only good for like tonight, so limited thing. That's all I got. Any questions? Yes?
So why do you like exceptions?
Why do I like exceptions? I'm not sure that I would say that I like exceptions. I don't like working in languages that don't have exceptions. I think they're very important to have. But one of the things that I like to talk about when I have a little bit more time is alternatives to exceptions, because there are actually a lot of things that you can do to avoid raising an exception at all, and a lot of times that's the right choice to make, especially in library APIs. There are a lot of libraries out there that just sort of throw exceptions willy-nilly, and they tend to drive the library users up the wall sometimes. So it's often nice to actually think about whether you really need to raise an exception or whether you can indicate that there was a problem in a less catastrophic manner.
I guess I've also found that if you're writing client code that's talking to some web service, the exception handling is really complex, because if you've got a really bad web service and it's not doing rollbacks and things, you might have to manage rollbacks yourself.
Yeah.
Yeah,
And it gets really complicated.
Answer.
Yeah, it's nasty.
Yes?
So just to follow up on that question, the thing that people do most commonly instead of using exceptions is they have different return codes or something.
Mm-hmm.
Like true or false with succeeded errors is very common in Rails. So what do you think the best way to go is in what situations using each technique?
It depends. There are, it really depends on what you're doing. I mean, I use that HTTP example in at least one of these, a couple of these, because that's where I see a lot of people complaining about the exception APIs. Like I've seen, there are HTTP libraries out there that'll raise an exception if you get a 404, and a lot of times 404 is not. It's not an exceptional case at all. I mean, that might be, for that API, that might be how you determine whether a job has finished, is whether a particular URL is 404 or not. So, in a case like that, if you can have just a response object, which you can then query for status, that often makes a lot more sense. And you see that in like the Typhoeus HTTP library. It never raises exceptions. No matter what happens with that request, whether it fails at a high level, whether it fails down in curl, you're just going to get a response object back, and you can ask that response object about what happened and whether it was successful or why it failed and stuff like that. Something else I like to do is I like to punt the decision up to the caller as often as possible. So like returning some kind of response object is one way of doing that, but another thing you can do is you can actually you can have your method take a block, which is the fallback action if something fails or something isn't there. And you see this in Ruby, you see this in the fetch method. So most of the Ruby collections, all the Ruby collections, will accept a fetch method, which you give it the key of the object that you want, like array.fetch or hash.fetch. You give it the key of the object you want, and you give it a block which says what to do if that's not there, and that block could raise an exception, or that block could just return some sort of benign value, which won't break anything. So that's another way I like to handle that is just to punt that decision to the caller. Does that answer your question?
Sure.
Okay. What else?
How often do you use some of those techniques, such as the retry, the splatting the exceptions list, and etc.? So,
all right, the answer to that is somewhat embarrassing. I do use retry semi-regularly. It's not something I use every day, but if I do have some kind of web service call or something that I need to retry, I will often use retry instead of some kind of loop. To be perfectly honest, the splatting of the really dynamic request or exception matching is something that I figured out you could do while I was researching the talk and the book, the original talk and the book that came out of that. And so I haven't had a lot of chance to use that in action since then.
Cool.
All right, great. Thank you.
Hello, just like the screen. Actually, I'll just put it on loud, and hopefully that'll work. Hey, my name's Joel, and today I'd like to talk about a project I've been working on called Beats. And Beats is a drum machine that you run from the command line, and it's written in Ruby. So back in the day, the first drum machines were actual physical devices, like a box where you press some buttons on it, like the Roland 808 here, play back your rhythm for you. These days, more likely to be in software, so you might have like a graphic interface like here where you can click around and put in a beat you want to play and play it back. And sometimes this is a smaller part of a bigger audio production tool. Well, Beats is a bit of a different take on a drum machine, because instead of a graphic interface where you click around, instead Beats runs from the command line. So you create a YAML file that looks something like this, and you can put in what you want to play and the sounds you want to use. You go to the command line, you run Beats, and it turns this YAML file into a WAV file that you can then play back or import into something like GarageBand or whatever, and build a bigger song on top of it. So there's a couple nice things about using a text file for this. First of all, you can just throw it into Git or Subversion or whatever, and you have instant history of your song. You have an instant backup. And also, if you're handy with a certain text editor and you use that to write all your code, well, now you can use it to create music as well.
What's a GoRuCo?
That is, I'm not actually sure. It's I have this old Casio keyboard where this file came from, and it's one of the sounds on it. It's like a bell type thing or something.
It's opposite of the stop sign.
It's what?
It's opposite.
It's like this little handbell that you hit with a stick.
Okay, yeah, it's a handball you hit with a stick. And all right. And so, like I said, Beats is written in pure Ruby, and this is a bit unique. So instead of being like a Ruby wrapper around like a C extension that's doing all the work, or like a Ruby controller for some other program, it actually does audio processing in Ruby itself. And the cool thing is that these days with a modern computer and a modern Ruby VM, it's actually fast enough that you can do this. All right, so without further ado, I'd like to just give a demo of how Beats works and some things you can do with it.
Is Joe gonna rap over it?
Yeah, I think Joe's been working on this for a couple weeks here. So.
Lay it down, Joe. I'd have to freestyle, so I don't have any lyrics, obviously. Exciting less.
Can everybody see that? Is that big enough?
Yeah.
All right. So right now I'm in command line. So first thing you got to do is install Beats, and Beats just comes with a gem, so you can do gem install Beats. And when you do that, it adds a Beats command your path here. So if I type Beats, I've got it installed and shows the help here. All right. So now I'm going to switch over to this window here where I have a couple sounds. There's some samples from some other drum machines. So it's we got a bass drum sound here. All right. Can everybody hear that? Is that loud enough?
Yeah.
Got a hand clap sound and a hi-hat sound. All right, so let's create a beat out of those sounds. So I also have this file, groove.txt here. This is just an empty text file. That's where we're going to build this. So I'm going to switch over to VI here. And all right, so we got a blank song here. So the first thing we got to do is add a pattern to our song. And so a pattern is just a verse or a chorus or a bridge or a certain fill or whatever. So let's add a pattern called a verse. And then every pattern has one or more tracks. So a track is just, for each sound you add a track and then you say what rhythm you want it to play. So let's add that bass drum sound. And that was the WAV file that we had for that. And let's just do something simple. We'll have it play 4 quarter notes. All right, so on the left we have the sound we're using. On the right we have a rhythm. And each X means to play the sound, and a dot means a rest, don't play the sound. And each extra dot is the 16th note. So this is 4 quarter notes here. All right, so this is a really simple pattern, but it's good enough to start with. And now we just have to tell Beats that we want to play this pattern. And we do that by adding a flow to the song. All right, so it lives in a special header here called song. It looks like a pattern, but it's just like where you can put global info about the song. And so we tell it to play the verse once. All right, so this is about as simple as it gets. But this is a valid song. And note that this is just YAML here. So the next thing is we go to the command line here. And I'm in the same folder that we were looking at with our file there. I just do Beats in the name of the text file. Enter. And it looks like it worked. So if I type ls again, you can see there's now a WAV file right below the text file there. So let's go back here and listen to what we did. All right, so nice. We got a nice little 4-on-the-4 rhythm going there.
I think you might be able to, on the command line, we do just open.
Yeah, there's on Max at least there's an AF play command. I don't know what open does, if that opens with iTunes or whatever, but
You know, good about
Did you
All
make
right.
it loop?
what's that?
Can you make it loop?
If you have a program that can loop audio, then it can do that.
Wave,
but-
can't you tell it to loop in the wave file?
Can you put
you
verse?
might be able to. I'm not sure.
Can you just add another verse and then it'll loop through the verse again?
Yeah. I'll actually do that in a second here, so I'll show you that. All right, so this is pretty simple. Let's do something a little more interesting here. So, And so this is a little more interesting rhythm here. You'll notice I added these bar lines here, so you can just use that to make it a little easier to read. You can put them wherever you want. It actually just ignores them. Let's add another track. So let's add that hand clap sound we had here. And let's have that play on the second and fourth beat of every measure here. I think I accidentally missed one of those. All right. Let's also add the hi-hat as well. Let's have that play every 8th note. Probably a faster way to do this, but yeah, that's true. Ah. All right, so we got something a little more interesting here. And also while we're at it, let's slow it down. So last time we didn't tell it how fast or slow we wanted to play it. So if you don't put that in, it just defaults to 120 beats per minute. So let's tell it to play a little slower. How about 105 beats per minute here? Let's save it. Let's run beats again. All right, we got our file created, and let's listen to what we did now. All right, so we got something a little more interesting there. And now that we have our verse, let's add another pattern here just to mix it up a little bit. Let's add a chorus. And let's add that bass drum sound again. All right, but now we've actually used the bass drum now in 2 different patterns. So let's say we add like 10 more patterns here, and we realized later on, hey, I wanted to use a different sound, so you'd have to change it to 10 different places. What you can do is add a kit. And you can give a sound a label like, say, bass. And then anywhere, instead of actually doing that raw wave file here, I can just do bass. And we'll play that instead. While we're doing that, let's add the other sounds here. Just give them a nicer label. And this is also especially nice if you are using like a path in your sound file name. It can get pretty hard to read there if you don't do this.
You didn't do a key.
Yeah, you're right. Thanks.
Oh, the clap is clap, steroids.
Yeah. It's close enough, right? It's like a snare. We'll call it clap. All right, and you don't have to line these up, but it just makes it look a little nicer if you do. So do that. And all right, so let's add our another different rhythm here for the chorus.
So is it always doing 4/4 or something like that? Or?
You can actually pretty much do any time signature you want, because it doesn't actually like keep track of measures or anything. So if you wanted to do like 3/4 or 6/8 or whatever,
Change your tempo and deal with it when you imported it into whatever else you.
yeah, you can do that too. Oh yeah, and like if you wanted a 30-second note, for example, you could just double the tempo.
Sometimes you'll want to like go really fast.
Yeah, yeah. So that's like a trick you can do there too. And all right, let's. All right, and finally let's add the hi-hat here, and let's make it go a little crazy at the beginning. Some 16th notes. All right, so we have our second pattern here called chorus. We just have to tell beats to play it, so let's go back up to the flow and put that in. And actually, let's have it play the verse twice and then the chorus twice. So we can just do this. Play each pattern twice. Go to the command line, run beats. Got a wave file. Let's listen to our final file here. Playing the verse again now. Now the chorus. All right, so.
You didn't just come up with that, did you?
Just right off the top of my head right now. And, all right, so this is the basic stuff you can do with beats right here. So we could add some more patterns or add some more tracks, make it more complicated, or whatever. But you notice like each time we had to do anything, it was sort of a little tedious. Like we had to make our change in here in the text editor. go over to the command line, run beats, go over to our folder here, listen to it, whatever, go back to the text editor. But the cool thing is if you have a scriptable text editor, you can automate some of this. So instead of having to do all that, you can make a change and listen to it from directly within the text editor. So right now I'm using them here, and I've created a script where that's mapped to some key combination on my keyboard. When I play it, it's going to automatically save the file, go to the command line behind the scenes, create the WAV file, and then play it. So you'll have to take my word for it, but I'm pressing a comma P on my keyboard here. And it just did all that right there. I use hit Control C to quit out of that. And so if you have a lot of patterns in your song, you maybe don't want to have to listen to the song every time. You just want to listen to that one pattern while you're working on it. So I have another script here where it figures out what pattern my cursor's in right now. So right now it's in the chorus pattern. So if I do this other key combination, it just plays a chorus. And so if we decide we want to change it, we want to make the snare drum go crazy at the beginning here, we can then just listen to that right away. So the cool thing is you can turn your text editor into a music studio here. Let's make that go back. So you can get pretty complex. Here's a song I've been working on that is a lot more than that one. And then let me switch over to this other song here too, because I said before you can import these files into something like GarageBand or whatever. So it exports to WAV, which is about the most standard audio format there is. Any program can use it. But originally, it was saving everything to just one WAV file. So if we want to make one of the tracks louder or pan something to the left or the right, or add an effect to one of the sounds, we can't really do that if everything's in the same file. So you can use the -S option. And when you use this, it saves every track to its own separate WAV file. So we go back here. There's now a groove, a separate WAV file for each track. So we can listen to the hi-hat by itself. And then you can, like I said, you can import these into audio production tool. So here's that file we were just looking at before. All these yellow tracks down here are tracks from beats, and all these purple tracks up here at the top are some sounds I got off an old synthesizer I had laying around. I was just playing around with that. So here's what that sounds like when you put everything together. So that's beats there. So if you're interested in actually using this or learning more about it, there's a couple of resources here. So here's the Beats website. It's at beatsdrummachine.com. And so this is just the homepage here. There's a download page, which is helpful. It tells you how to install Beats. It's just gem install Beats. And then also there's some free drum sounds you can download. Because if you don't have drum sounds to use, it's not very useful. You can't actually do anything with it. So here's some sounds you can download to get started. Exactly, yeah. So it's definitely Casimir keyboard quality here. This is the best one. All right. Also, Beats is on GitHub, so check it out here. And there's also a wiki for Beats. And so one helpful page is a Getting Started page where it's like a tutorial. It's sort of like what we just did here. It shows you how to create a song from scratch and the basic features and stuff. And then if you're interested in how Beats actually works behind the scenes, there's a How Beats Works article here where it goes into how it actually works. All right, so that's what I got. Let me put up a slide here with those URLs here. But that's it.